Under the theme of the brief description of compressed air systems, I will talk about the basics of compressed air. The contents of this course consist of the following 9 items. 1. Intended uses of compressed air. 2. Units of compressed air. 3. Indications for flow rates of compressed air. 4. A system flow diagram. 5. Selecting air compressors. 6. Selecting air dryers. 7. Selecting air filters. 8. Selecting air tanks. 9. Compressed air pipelines. One. Intended uses of compressed air. Compressed air is widely used to drive various manufacturing apparatuses and is the air supply for equipment including air cylinders and air guns. The compressed air is released into rooms after it is used. Therefore, for processes including that of semiconductors, the use of dust, oil, water, and chemical components is strictly restricted. The advantages of the use of compressed air are as follows. 1. Through pressure regulation and modulating flow, outputs can be easily adjusted. 2. There is not risk of explosion or ignition. 3. It can absorb impacts if it is imposed on shocking loads, because it is a compressible fluid. The disadvantage is that draining occurs. 2. Units to be used in conjunction with compressed air. The International System Unit Pascal is used to express pressure of compressed air facilities. Conventional units may be also used. It is important to also learn the conventional units, because they are also used, and so you can convert the two types of units with each other. The general values of operating pressure are 0.5, 0.7, and 0.9 megapascal. It is convenient to remember these numeric values along with the corresponding conventional unit values. Pressure is shown by the two methods shown on the slide. Gauge pressure is used to indicate air pressure. In addition, character G may appear after the unit of pressure if gauge pressure is used. Three. Indications of flow rates of compressed air. The normal air volume is used to indicate flow rates of compressed air. Flow rates are indicated by the unit of the normal cubic meter per minute. The normal air volume is the air quantity under the conditions of a temperature of 0 degrees Celsius, an atmospheric pressure of 1, and an absolute humidity of 0. The standard air volume and the free air volume may be used to indicate airflow rates. The standard air volume is the air quantity under conditions of a temperature of 20 degrees Celsius, an atmospheric pressure of 1 and 65% relative humidity. For example, in Tokyo, you can calculate the air quantity when air comes into the inlet port of a compressor by using the free air volume. You can calculate the air quantity with the free air of a temperature of 40 degrees Celsius, an atmospheric pressure of 1 and 41% relative humidity. In this way, there are some methods to calculate the quantity of compressed air. However, you must consistently use the normal air volume for the calculation of compressed air to ensure smooth task operation. You can see the conversion formula for the normal air volume on the slide. 4. System flow diagram. A system flow diagram for standard compressed air systems is shown on the slide. From the left side of this drawing, the components are air compressor, air tank, pre-filter, dryer, point of use. An air compressor is the equipment used to compress air and to produce high-pressurized air. This example is of an air-cooled type air compressor. For cooling, it is equipped with a water-cooled type air compressor. The air tank is installed to respond to variations in air consumption at the point of use and to prevent changes in pressure generated by the air compressor. The pre-filter is used to prevent dust from coming into the dryer. The dryer lowers the compression humidity of the air. The after filter collects dust discharged from the dryer. The final filter is installed to secure the cleanliness of the compressed air required at the point of use. To enhance the reliability of manufacturing systems, however, it is important to know that the point of use is the equipment directly connected to such systems. 5. Selecting air compressors. The air compressor is selected based on air mass flow and discharge pressure. Generally, the free air volume is used to indicate flow rates of air compressors. Consider the flow rate of air supplied by air compressors when you select them, because the conditions of sucked up air affect such flows. Discharge pressure is the sum of the pressure required at the point of use, the resistance of the pipelines, and approximately 0.1 megapascal of pressure required for starting and stopping the air compressor. From the various kinds of air compressors, select oil-free type screw compressors for general intended use. If you select refueling type compressors, separation units for oil used in drain treatment should be installed. Today, I will talk about the basic points of ventilation systems. Selecting air dryers. This time, I will with a loaded point, namely, ventilation dry air is required at the point of ventilation. Based air dryers are installed for dehumidification. Based on dehumidification methods, mainly select an air dryer from the following two types. On the content show cooling type. A freezer cools compressed air to 2 to 5 degrees under the Celsius, which is slightly higher than the freezing point. As a result, atmospheric steam is thereby condensed and removed as moisture. Subsequently, the temperature of the air is returned to the normal temperature and dehumidified. Absorption type. Absorbents including silica gel, activated alumina and synthetic xylite are used. Moisture absorption and regeneration are repeated in turn. Dry air is therefore supplied continuously. If the dew point temperature under pressurization is 10 degrees Celsius or higher, select freezing type air dryers. If a low dew point at below 10 degrees Celsius is required, select absorption type air dryers. The absorption type air dryer requires purge air. Note that purge air requires approximately 15% of air inlet flow when you select the capacity of the compressor. The standard air volume is used to indicate flow rates of the air to be processed by air dryers. The flow rate of air processed with air dryers changes depending on the condition of the air at the air entrance. You must convert the flow rate into the standard air volume. 7. Selecting air filters. 3 kinds of air filters are used. They are pre-filters, after filters, and final filters. The pre-filter is installed to collect large dust particles, separate moisture, and protect dryers. An after filter is installed to collect the dust discharged from dryers. The final filter is installed to maintain the cleanliness at the point of use. In addition, an active carbon filter is installed to remove undesired substances including atmospheric oil and gases. The standard air volume is used to learn about flow rates of air psychrometric filters. I will explain the basics of psychrometric charts. It will also be a review air tanks about choosing an air tank. The air tank is installed to secure load and unload cycles of air compressors, to separate drains, and to respond to suddenly increased air consumption. Select materials for air tanks from metals including steel and stainless steel based on the quality of the required air. Set load and unload cycles of air compressors to be 60 seconds and calculate the capacity of the air psychrometric chart. The calculation formula on the slide is used to calculate the capacity of the air tank. It will also be a review. 9. Compressed air pipelines. Pipelines for compressed air. Compressed air pipelines include white gas pipes, copper pipes, and stainless steel pipes. The air on psychrometric. If a higher level of cleanliness of compressed air is required, copper pipes and stainless steel pipes are required because their surfaces are smoother than that of white gas pipes. The stainless steel pipe is divided into two types called BA pipes and EP pipes, based on the conditions of their internal surfaces. For example, when you select piping made of a certain material, you can select white gas pipes for the segment up
you will
to
learn
the air
about
dryer,
understanding
while you can
psychrometric
select
charts.
stainless steel pipes for the subsequent segment. In semiconductor factories, BA pipes made of stainless steel are often used for the segments behind final filters. Use valves made of the same material as the pipes to be used. Use ball valves. For all pipelines and valves, treated oil-free. Compressed air pipelines. Selecting pipe diameters. A pipe diameter selection guide for stainless steel pipes is shown on this slide. To determine the pipe diameter, providing that the pipe can achieve a pressure drop at a flow rate of 15 meters per second or slower, and a pressure of 500 pascal or less per meter. Determine the pipe diameter so that the pressure drop per meter for the main pipe can be 300 pascal or less. Furthermore, select the overall pipe diameter to achieve a pressure drop
Under
of
the theme of
10%
designing
or
a
lower
piping
compared to the
system,
initial
I would
pressure
like
from
to
the air
explain the
tank to the
basics
end
of
of
the
the piping
equipment.
system. Determine the diameter suitable for the systems to be used and the places where they are to be used. Read the engineering data book, because methods of how to determine diameters are summarized in a document about compressed air facilities. This is an end of the explanation of the brief description of compressed air facilities.